Hello and welcome to Database Management Systems. I'm Javita Christie, and in this video, I'm going to explain to you database security, a brief introduction to how modern databases are made secure. So let's begin. Modern databases use the following approaches to make databases more secure. The first of these approaches is called Discretionary Access Control, or DAC. The second approach is called Mandatory Access Control, or MAC. And the third approach is called Role-Based Access Control, or RBAC. Let's take a look at Discretionary Access Control first, which is the most commonly used security approach in modern databases. Here there is a user, and the user is given access to different files, and the user can access only those files which are allowed. And there are different types of accesses also, which we are going to see later. But this is the most commonly used approach because it's very fast and it does not provide a lot of security, but it's enough for our day-to-day usage. So this is the approach, a very simple approach where a user is given access to certain files, and so he or she can access only those certain files. Let's see what are the different types of accesses which can be provided for discretionary access control. So the different access modes are, the first one is the simple read mode. So this is where the user can only read different things from the file. Then there's the write mode, where the user can only write something into the file. And then we have the execute mode. So if you have a .exe file and you allow the user to have an execute access on that file, then the user can run that file. Then the user has the delete access mode. Delete access mode allows the user to delete the file if he so wishes to do so. And then we have the null mode. The null mode means there is no access mode given. That means the user has no rights over that particular file. And then we have the control mode. This means the user can control that particular object or file completely. And finally, we have the control with passing ability. This means the user not only has complete control over the object, the user also has the right to pass this control on to someone else. That is what control with passing ability means. Now, to handle all these modes, there are different tables created, which are known as access control matrix, and we are going to see that now. So what you see here is called the access control matrix. The access control matrix actually shows you which user has access to which file and with what type of mode. So you can see some places it's written RW. RW means read and write. Then there is just C. C means control. Then there is CP. CP means control with passing ability. And that's how this type of a matrix is created. And you can see on the left-hand side, there are different types of users. Those are the names of the users. And on the topmost row, you can see different types of objects. These are different files available for access in the database. And you can see next to Kim over here, it is written RW. So RW is written under Kim's file, which means Kim has a right to read and write into Kim's file. And this is how this type of a table is created. If you see MGR, which stands for manager, which is right here, you can see that in this case, manager is having CP on 2 files and then C on 3 files. So that means manager has control with passing ability on Kim's file and Don's file, and he has control over the remaining files. So this is how a discretionary access control mode works, by creating access control matrix. Okay, now let's take a look at the mandatory access control. The mandatory access control works also on the same principles of discretionary access controls, but the access is given in a slightly different manner. Here, access is given not just on the basis of how users are associated with files, but also how files are associated with users. And you might have if you have watched any crime fiction series, you might know that, some files are classified. So that means the person who wants to access the file does not have enough security clearance to be able to access that file. And that is why it is known as a classified file. So the same thing is available here in mandatory access control. A classification system where not only users are classified, but also files are classified. So each user is given a level and a file is given a level, and only if the level matches, then the user is able to access the file. You can see here users are divided into all these types of levels. So there's a level 1 user, level 2 user, level 3 user, and just like that, files are also divided into levels. So there's a level 1 file, 2 file, level 3 file. So only if the user is at level 1, he can access all the files which are from level 1 to 3. And the same way, if user is on level 2, he can access every file on level 2 and below. So this is how mandatory access control works. And before I go to role-based access control, let me tell you when mandatory access control is used. Mandatory access control is used mostly in military applications where security is a priority. But it also slows up the process because there's so much security given that you need to match every user with every file, and that's why accessing those files is slightly slower than discretionary access control. Now let's go to role-based access control. Role-based access control is done in the same way as discretionary access control with very few differences. So first of all, here, individual users are assigned to different roles. For example, user is an employee, or user is a manager, or user is a sub-manager, or something of that sort. Then roles are also centrally managed by the administrator. So the database administrator decides which role to assign to which person. And then security groups are created for each role. So for example, if a person is just a simple employee or a clerk, then there is a group of clerks created, and then this security group is given certain accesses to certain files. And as you can see, each user is added to some particular security group. And also, this is known as non-discretionary access control because there is no discretion. Every user is allowed the same kind of access as the people that he or she is in a group with. So if you are grouped as a clerk, then whatever access is given to all types of clerks is also given to you. So this in a way helps you because you don't have to create a matrix where you have to add each and every user. You can just add each and every security group, and you can assign files. You can decide which files can be accessed by a person in that particular security group. So this is how role-based access control works in DBMS. Although we have all these approaches for providing security, we cannot protect the system against malicious SQL commands because every user is allowed to write SQL commands. And while writing these commands, they might try to write a command in such a way that it harms the system. So in order to protect against such activities, we use intrusion detection. So this is something that comes with your software, which is called intrusion detection. What intrusion detection does is, first of all, it logs all malicious activity in the database. So whenever it finds that some activity is happening which shouldn't be happening, then it creates a log of such activities in the database, and immediately notifies the administrator so that the administrator can take some action against this type of an activity. And intrusion detection could be an external hardware, or it could be also a software. It audits all the system files and configurations. So it doesn't just take care of the database, but it also takes care of your operating system and all the files within your system in order to protect them against any attack from the database. It also analyzes the attack patterns. So if there is a specific pattern of attacks, then this pattern is also analyzed by intrusion detection software or hardware. And it also monitors user and system activities. So not just users' activities are monitored, but also systems activities are monitored in order to make sure that there is no malfunction or behavior that is not common. There are different models of intrusion detection. The first one is called misuse detection. So this is the model where the intrusion detection software or hardware tries to check whether all the activities that are occurring are violating any of the system parameters. If anything within the system, any of the rules are violated, then immediately intrusion detection would maybe sound an alarm or inform the administrator. The second type of intrusion detection model is known as anomaly detection. So anomaly detection is where the intrusion detection software or hardware is constantly on the lookout for some sort of a behavior that is abnormal to the system. So whenever any type of behavior that is not normal or common or that usually happens is occurring, then immediately the intrusion detection system catches it and logs it into the system. Now next, let's study SQL injection. SQL injection is one of the most common techniques of infecting the database, and let's see what is an SQL injection and how it is done. Now, SQL injection is nothing but a code that is injected into your database in order to destroy it. So that is what SQL injection is. It's nothing but a simple code that is passed into the database, and that could affect or harm your database. It is also one of the most common web hacking techniques, and it involves placement of a malicious code into SQL statements when you are filling, say, some web forms or something. So when you're filling these types of forms, there might be an SQL injection which is injected, and this could harm your system. Let's see this with an example now. So consider this statement that is given right here. You can see it. So here I have the text user ID equal to get request string. Now this is nothing but a PHP code, a very small PHP code. But what exactly it does is you don't need to really know how this other programming language works. You just need to understand that when there's a form involved on any kind of a web page, then on that form you will see a user ID column or user ID section where you enter your user ID. So this particular line of code actually accepts that user ID and then processes it. So this is a code that is written in order to process a user ID. Now this is my SQL query. So I have written select star from users where user ID is equal to. Now you can see that the variable I've used here is the same variable that I used here in order to get that particular user ID, which the user has entered into the form. Now, afterwards, just try to understand what if the user tries to enter this type of detail. Now you see the user ID entered is 105, but after that there is a statement written which is OR, and then it's written 1 equal to 1. Now what happens exactly is this 105 or 1 equal to 1, it gets stored in the text user ID. And then from the text user ID, it gets stored in the SQL query, which is right here. So your SQL query that's going to run will look something like this. You can see. So it's going to be select star from users where user ID equal to 105 or 1 equal to 1. Now, consider this for a minute. Just for a moment, think about what this query can produce. First of all, we are trying to do select star. So that means we are going to get everything from our table, which is users. And then the condition applied is user ID equal to 105. Now this 105, user ID equal to 105 may or may not match any of the rows. But the next condition given is OR. So when I'm saying OR 1 equal to 1, 1 equal to 1 is always true. So whenever I enter this type of a condition that says 1 equal to 1, then this query will always result in giving me all the rows, because 1 equal to 1 is true. It doesn't matter what row it is. So when we write it like this, then this query will produce all the rows of the user column, of the user's table. And now you might think that that's okay. What difference does that make? But think of the users table. What if it contains the user IDs and the passwords of all the users? Then the person who has filled the form in this manner will be able to get access to this entire table of user IDs and passwords, and that is how hacking can be done. So SQL injection is one of the most common techniques of performing hacking, and the solution to this is not using this type of a variable directly into an SQL statement. Maybe you need to process it or something in order to process, in the sense maybe use some regular expressions in order to make sure that this user ID is actually a user ID and not some part of an SQL statement. That's the only way you can prevent any harm being done through the SQL injection. So that's it for this video, and I'll see you in the next one. Thank you for watching.